a little bit more discomfort for me, but so come on. We saw a very good presentation from Marianne about the situation in Phoenix, and I'll show you something different because it's primarily focused on urban greenery scenarios, but in Prague and using, sorry, I'm not able to say it, but it's a little bit more complex model.
Not my model.
Yeah, it's a strictly modeling approach, so you will see the results from the first. Okay, it's not working. These results are the maybe the first part of the campaign which we want to make, and it's primarily focused on urban greenery and its shading scenario in the realistic street level. Why we want to do it? Probably the most popular adaptation or mitigation measure, especially in the Central Europe, is the planting of trees. Still, a lot of people working in administrative, especially, are still thinking that tree will mitigate air temperature during the heat wave episodes, and they will mitigate it about 5 or 10 degrees of Celsius. We try to explain it's not so true, and there are also much more important problems related to trees, like their positive reaction with, for example, biometeorological indices, and they are also mitigating land surface temperature or surface temperature, but they can also make something worse, especially in case of air quality. There is still a lack of studies dealing with the air quality using some more complex model or more complex data. That's the reason why we did it, at least this first part of the scenarios. And we also try to interpret it and a little bit tune it to push this knowledge a little bit forward. Our design experiment is based on the semi-realistic domain. It means that all the meteorological data are valid for a real heat wave in Prague. It was occurred in 2022, if I remember well, and we just virtually move it from the middle of July, to the middle of the June. And we also prepared semi-realistic domain. It means that we are not using the real situation in Prague, but we need to analyze the highest effect of these trees in the urban canyon. So we prepared very long canyon, which took more than 5 kilometers, split it to the parent domain and then to the child domain, and then run it in the Palm simulation. At the end of this work, we evaluated some small domain only in the pedestrian level, but importantly say only in the northern part of this domain, because we want to see what exactly has happened on the most irradiated part of this domain. If we will try to analyze these effects in the south part of the urban canyon, which is east-west oriented, as you will see later, we will see the effect of the building shading. But we are not interested about effect of buildings. We want to see what exactly are doing trees in this case. So, as I said, we have semi-realistic domain. So we have real buildings with the real parameters and real settings, like window fraction, insulation, plaster, bricks parameters, all these things. We have also very detailed information about the surface, and these parameters are the same for all scenarios. There are also differences in 3 parameters. It practically differs between the spacing of the tree inside the canyon. The main purpose is to cover 0% and by 10% interval, the 100% of the domain by the trees. In total, we get a small issue. The tree crown is not a cube in the real situation, as you already know. So we need to use oval crown. So it means that in the realistic point of view, it's not 100% shading. It's still some small gap between the trees, and the tree crowns are not overlapped in this case design. So As I mentioned at the beginning, local administrative still thinks that tree will mitigate or reduce air temperature in the closest area of the tree. As you can see, it's not possible technically. The colors are practically the same, and practically it proves that trees mitigating not only its closest area, because the air is usually well mixed and the differences in the air temperature are very low, but they are mitigating, if you have a lot of trees, the whole domain. You can see the differences for a scenario of 100% and also for a 0% or 50% scenario, but these differences are quite low. So it means that the effect of the planting of the tree and its effect on mitigating water temperature is very low. It also will vary, I will show it a little bit later, but it's very low. During the daytime, you'll see that at the morning time or in the early afternoon, is it practically air temperature the same for all scenarios. The differences are primarily in the nighttime phase or in a late afternoon. But it's completely changed in a case of surface energy or energy balanced variables, like surface temperature. Here you can see that for a scenario without any trees, you have no shade on the northern part of the canyon, but there is clearly visible the shade of the buildings, as I mentioned. If you plant, for example, 50% of trees in this example, you will see the effect of each tree crown, which how to reduce land surface temperature in the straightly close area of each tree. There's also very good example for a 100% scenario. You can see that trees planted in the northern part of the urban canyon do not mitigate it part in the center part of the street and also in the southern part of the street. The effect of this mitigation is also differs during the daytime. During the nighttime is quite low. Everyone expected because there is no radiation, so the effects are quite slow. But during the daytime, there are some differences. If you have a larger percent of tree canopy in the urban canyon, so the mitigation, also the maximas and averages, is quite important. In case of minima, is it practically not different. Similar results are for mean radiant temperature. It's also another one energy balance related variable. So there is practically the same result as for land surface temperature or surface temperature. UTCI or biometeorological indices generally, they are both based on MRT, so the reaction of the model is practically the same. There is a net radiation flux for all the scenarios. Important thing is this peak for 100% scenario. The trunk in our model is 5 meters high. So it means that during the lower solar angles, is a human staying in close to the tree on the northern pavement is sometimes irradiated by solar radiation. So those are those small peaks. But in the half noon, is it sun strictly above the tree, so you are completely shaded and there is practically no radiation under the tree crown. But what does it mean for air quality? In case of air quality, we have no daily average as is usually published somewhere, but we have hourly disaggregation of the data. So you can clearly see that this is a morning time where people traveling to the work, and you have a lot of trees in the part of the street. So the situation is a little bit worse than zero planting scenario. Practically the same situation is during the afternoon. So it means if you have a lot of trees, so there is a higher probability of air quality complications. Currently, we are working only with PM10 particles because currently it's running only passive tracing of these particles, and the ozone chemistry will be implemented in the next phase. So it means that we'll be able to analyze also nitrogen oxide and nitrogen dioxide. But currently, we have only PM particles. Some conclusions for ending of the presentation. As was proved by many studies, trees and urban canopy has an important effect on especially energy-related variables in the urban canyon. But it has also negative effect on the air quality. Our results, which we are currently working on, have a quite good agreement with the results of the model. So we think, we are not completely sure because this type of experiment is really hard to validate, but we are quite sure that these results make sense. And I hope that the final results of this study will bring something new to our community, and especially in case of urban greenery and its style of planting in the streets. So thank you for your attention.
Very interesting modeling exercise. I see hands already. Maybe we start in the front and work ourselves to the back.
Thanks very much for this great study. I have a question regarding the air quality. So first is a comment that actually the air quality in the same street may get worse, but of course then on the same side, air quality in the next street improves as there's less dispersion. The question is on the model. Does that account for dry deposition? Because I think that the compound effect of particles on the tree leaves can actually maybe compensate for something.
Yeah, in this case, dry deposition was switch on, so we had it. But in case of PM10 particles, especially in this type of study, we think that the effect of dry deposition will be very low. It means in case of 2 or 3% is rough estimate. So we think that if it will be possible to analyze it, it will be still some statistical error maybe. It will be definitely very low.
We have the microphone in the back.
Yes. Thanks for the nice presentation. Since you found that the effect is so low, how do you explain that cities that observe high proportions of street cover in general do observe also very lower mortality during heatwave events?
Can you please repeat it? I didn't hear it correctly, probably.
Since you observe that the impact of trees on the air temperature is so low,
Yeah.
how can you explain that the mortality during heatwave events will still be really significant between places that have higher tree coverage than other places?
It's a very good question. To be honestly, I don't know how exactly to explain. Yeah, there is from my point of view, is that people usually, how to say, they prefer something different as they are expecting. Yeah, I don't know is it the right term, but
So maybe I can help you, Jan.
yes.
Within that question, there's also a socio-economic effect that you shouldn't forget when it gets to heat waves and trees and greenery and so on. We've got some studies from the US that were showing that there's a high possibility that you have the less socio-economic equipped people in neighborhoods that have less greening, and that also drives.
This is usually controlled for. So you really observe that temperature, like the simple, like it is something that is a bit triggering me. I also observe in the simulations that I made that tree is having a very low impact on that temperature, and still you find a significantly lower mortality. where all of those aspects, socioeconomic aspects, are usually dealt with.
I think we have to take that discussion offline and out of the room. The gentleman with the white jacket in the room, I ask you please to talk with Jan after the session,
Okay.
so we can move on.
I think it's very important because you mentioned it about particulate matter. As I understand, you consider primary aerosols, right?
Yep.
If you consider organic secondary aerosols, interaction with vegetation will be much welcome. And without leading that, no guarantee what your answer will be right. So definitely you have to care about secondary organic aerosols which are produced also by vegetation.
Thank you for your point. Agree with you, and I hope that in the following results will be a little bit better and more tuned for that. I also think that the current dry deposition in Palm has some minor bugs, so we will see. As I said, it's our only preliminary results.
More work, always good. Thank you very much. Let's take Jan.